Okay, so we're getting pretty deep into chapter 18 now. We've had our thorough discussion of the amines, we've started our discussion of the amides, and hopefully everything is coming together nicely for you. Specifically in this lecture, we're going to focus on the hydrolysis of amides. So we talked about amidation, where we take the carboxylic acid and the amine, and under conditions of heat or enzyme function, we can make the amide and water. Well, now we're going to go in reverse, and we're going to take the amide and water and hydrolyze, break with water into the carboxylic acid and amine. Okay, so there it is, hydrolysis, the reverse reaction of amidation. So hydrolysis, from the Greek word hydro for water and lysis for separation or splitting, is a chemical reaction during which molecules of water are split into H plus and OH minus, and it occurs when water reacts with an amide in the presence of an acid or base reacts with an amide. So that's how we take that amide, or a lot of these things that we've made this semester through chemical reaction involve water as a byproduct. So here we're taking water as a reactant and breaking down that structure that we had made using the heat or whatever chemical conditions in the first place. Now, if you remember the end of the previous chapter on lipids, we could do acid or base hydrolysis in the lipids, and we'd end up with the glycerol and fatty acids in the case of acid hydrolysis, or glycerol and the fatty acid salts in the case of base hydrolysis, which we called saponification there. This time around, we're taking amides, and in the case of acid hydrolysis, we're forming carboxylic acids and an ammonium salt. In the case of base hydrolysis, we're forming the salt of the carboxylic acid and then a neutral amine or ammonia molecule. So it should make sense, right? In the case of the acid hydrolysis, because we're going to inevitably have extra acid around, the carboxylic acid molecules will be all protonated, and the ammonium salt, the amines or ammonia itself, will also get protonated by the excess acid. In the case of base hydrolysis, now we're in basic conditions, so the amine or ammonia will stay neutral, but we're going to deprotonate the carboxylic acid to form its salt. So hopefully that's logical, and you can keep that straight, and that will help a lot understanding these hydrolysis reactions. Let's take a look at acid hydrolysis of amides first. So we have the acid and a water molecule in the presence of heat, or biochemically in the presence of enzymes, will produce the carboxylic acid and the ammonium salt here. So here we're looking at ethanoic acid or acetic acid. It was ethanamide or acetamide by common naming. And we've made now ethanoic acid or acetic acid along with ammonium chloride, right? There's excess HCl present, so we get the ammonium chloride instead of the neutral ammonia. Now, if we take a look at base hydrolysis, when we have base hydrolysis of an amide, we have a base and water, and we produce the salt of the carboxylic acid because the base will deprotonate the H, the acidic hydrogen on that carboxylic acid group, and then the amine, because we're in basic conditions, the amine or ammonia will stay neutral. So here, if we take N-methylpropanamide or N-methylpropiamide by common naming, and sodium hydroxide and heat, or again, we wouldn't use sodium hydroxide biochemically, so I guess this is really more a lab scale reaction rather than a biochemical reaction. And it would make sodium propanoate a salt, or if we're using the common naming, it would be sodium propionate. And then we'd have the methanamine or methylamine for the neutral amine byproduct. Okay, so let's stop here and see how well you're doing with at least base hydrolysis. In this learning check, you're asked to write the equation for the hydrolysis of N-ethylpropanamide with sodium hydroxide. So go ahead, pause the video here while you write that chemical equation out, and start us back up when you're ready to check your work. Good luck. Okay, so hopefully this is the same solution you ended up with. We have our N-ethylpropanamide and the sodium hydroxide that we were told we would have. Notice it's a single-sided arrow. This is a strong base, so we're going to favor completion type reaction here. And we make sodium propanoate, the sodium salt of that carboxylic acid, and then ethanamine as the co-product. So hopefully that's what you arrived at. If that's not the case, if you struggled with this one, please do try some additional base hydrolysis practice problems. Reach out to me for help. But let's go ahead and follow up with a learning check on acid hydrolysis. Okay, so as promised, here we go. Let's have you write the equation for the hydrolysis of N-ethyl propanamide with hydrochloric acid. So please stop the video here, go ahead and write that equation, and start us back up when you're ready to check your work. Good luck. Okay, so we're starting with that same N-ethyl propanamide, so hopefully even if you struggled with that in the base hydrolysis, you've got the structure down here for the acid hydrolysis. And notice this time we're going to end up with the neutral propanoic acid because we're in acidic conditions. We're going to have the neutral acid form. And then we're going to have ethyl ammonium chloride, the protonated amine product, as the co-product. So hopefully between these learning checks and the lecture itself, you're feeling more comfortable with base hydrolysis, acid hydrolysis, what the distinctions are. Again, in base hydrolysis, you get the salt of the carboxylic acid. In acid hydrolysis, you get the salt of the amine or ammonium. So there we have it. Hopefully, with some additional practice if necessary, you'll be ready for the exam come exam time. If you're feeling uncomfortable with any of this, you've tried the homework set, you've tried some additional practice problems, it's just not making sense, please do get in touch with me. I know these reactions can sometimes cause people some trouble, and I'll try to give you some advice as best I can. Otherwise, if things are going well, as I hope they are, we'll see each other for the last lecture of Chapter 18.